Hello and welcome to this video on generator functions and generator expressions. Till now we have seen functions which use return statement, but generator functions use yield statement instead of return statement. And suppose there are multiple results to be returned, then it returns one result at a time. And it suspends and resumes the states between each invocation of the generator function. Generator expression are similar to list comprehensions which we have discussed in our previous video, but they return a generator object and produce result on demand. They don't build a result list. Because of this reason, generators save memory and can have higher performance in larger programs. They also provide a simpler alternative to manually saving the state of an iterable across different invocations. Excuse me. And with generators, variable accessible in the function scopes are saved and restored automatically. That you will see very soon. Generator functions may also have a return statement, but it is not necessary. This return statement simply terminates the generation of values by raising a special exception called stop iteration. A generator function always generates stop iteration when it terminates, and next function, the underscore which we have discussed in our iteration protocol, that is what is used to resume the function and runs until the next yield result is returned or stop iteration is read. So first I will code and comment this portion of code, and I'll focus on this. So I have a generate square function which takes an integer input and for that value from 0 to n minus 1, it raises the power to 2. So now if I call this yield statement is here rather than return statement. You don't build a list and then return, but rather you yield. So for this I have invoked this, and this prints the return value. So I'll comment this out. So let's see what it does. What it should do is it will print 0, 1, 4, 9, and 16. Let's see this in action. Yes, that's what it printed. Now, if we comment this section out, for example, not this, this one. Now we create a generator object here, x is equal to generate squares 3. Then the type will be a generator class, and you can call next on this x to print various values. Let's see that. Let's print this also. Now you see we have x for value 0, 1, and 2, but we are invoking it 4 times. Next has been invoked 4 times. This will cause an stop iteration exception to be read, which we are not catching, so the program will terminate. You see, there is a stop iteration exception which has been generated by the line number 33. If we go to 33, that is this line. So much for our iteration function. Now we will look at something called send function to a generator function. So what send function does is that it accepts a value which it will pass to the generator, and generator can use that value to do some action. For example, a special treatment of the logic, or maybe terminate this. So in this case, yield becomes an expression rather than a statement. So it can appear both to left side or right side. But if it appears to right side, then it should be in parentheses. For example, if you see this comment here, this is okay. But this is where parentheses become mandatory. You simply can't return yield y over here. Now, the uses of generator function is that, I mean, send method in generator function is that the caller can terminate or something or redirect to a new position in data. So here I have a gen function, which is a generator function, and for I in range this, I yield I and plus 10, and then I print 10. So when I call next of G here, then what it will print? It will print 0. And then when I send it 20, then it will print 30 and 1. It will print two values. So 20 will be sent here and 10 will be added. So X will become 30. And then the value of next state of I will also be printed. Let's see this in action. So first it printed 0, the yielded value of I, and next time it yields two values. One is 10 added to what it received in send, and then what we have I is next yielded value. So that's how generator functions work in Python. Now let's look at generator expressions. So consider this for example. So this is a list which will raise to the power of 2, a value to the power of 2, and the value is between 0 to 9. So this will form a list. So it forms the list in one's go. It's a list comprehension. But if you see this, it's a generator. Okay, you will see, for example, if you want to see the output, let's see that. So that is a generator object. So it will not generate all the values in one time, but it will generate one by one. For example, I have a generator object here, the same which we have here. The generator expression is G, and then I can invoke next G on this and it will print those values. Let's see this. So it generates 0, 1, 4, 9. So it generates one at a time. And as it travels, generator expressions can appear in for loops, sum, map, sorted, just where you can use a generator function call, you can use a generator. For example, here, look at this generator. This is our generator expression. So it takes for x in hello world, splits that based on comma, and then transforms that to uppercase, followed by join with a space in between, which prints our hello world. So generator expression has the same benefit in terms of memory and performance like a generator function, and it is also simpler to write generator expressions compared to what you can do with a map or filter. Generator expressions are simpler. So this is where I'll end this video. If you have found this video informative, please let me know in comments. And if you like videos on certain topics, then please let me know in comments. And if you really like this video, then please subscribe to the channel and like the video. Thanks a lot for watching. Happy programming.